Hello and welcome. In this video we will be designing the layout for 2 input CMOS NOR gate. So as you can see, this is our NOR gate schematic. The 2 PMOS are connected in series and the 2 NMOS are connected in parallel. So let us go into the layout. So this opens the layout window. Let me maximize it. So now you can see we will first generate all the pins from the schematic. So we have generated all the pins. So you can see there are total 5 pins: VDD, Vout, ground, and the 2 inputs A and B. And we have 2 PMOS and 2 NMOS. So to see the inner schematic, press the Shift plus F key. So as you can see in our schematic, the 2 PMOS were connected in series. So we will also connect them in series here. So when we connect them in series, then these 2 transistors are getting abducted. So the abort server must be on for this to happen. So just let me connect them and they will automatically be aborted. So you can see here these 2 PMOS transistors combined, and now we have these 2 gates. The gates are in green and the 2 terminals because they are in series. So the drain of the first PMOS is the source of the second PMOS. So now we can also stretch this working area. So this white square that you see is called as the PR boundary or the active area. So we can stretch it by using the S key. So press the S key on your keyboard and just stretch. So let me do that again. So you can see this is the working area. Now I press the S key and you can see we can stretch it. So we can stretch the area so that we have the more space and we can work more easily. So as you can see, this is the PMOS, the source and body. So the terminals are there but N-well is not there. So we will create a N-well. So we will create a N-well at the top. So as you can see, a N-well is created at the top. So we can adjust the transistors to connect them more properly. So let me adjust. So we have to connect it properly. First, so I will try to connect it. Yes, now it is properly connected. So as you can see, now as you can see, the second transistor does not have well, so we will simply stretch this N well. So just go and create a rectangle. So we will stretch the well for this PMOS to include for the second transistor also. So as you can see, now we have created a shared well. So the well is shared among both the transistors. Now we come to the NMOS. So the 2 NMOS are connected in parallel. So we will also combine them for a parallel connection, and so just I will zoom in to make sure that the we are combining them properly. So just wait. We have to overlap these 2 active areas. The white areas is the contact point, so we have to merge them properly. So we have to be very precise in this, otherwise it will give us errors. So as you can see, now we can see these two white areas. Now we will have to merge them. These white contact points have to be merged. So yes, now these are merged properly. So we have completed the connections of the transistors. Now we will complete the connections of the circuit. So just we will take the help of the navigator. So as you can see, when I click on VA, then it shows the connections. So we will make the similar connections. So we will take a polysilicon and we will connect the gates. The two gates are shown in green color. So we will connect them using a polysilicon. So at present these two gates are not in a straight line. So just let me adjust. Yes, now you can see I have connected the two gates. So to make the connection, just click on P, press the P key and click enter. So let me show you. Press the P key. So it will start and just click on enter where you want to end the connection. So using the P key creates a path of a fixed width. So again let me show. P key and press enter. Yes, so a path is created. Now I will merge it with this path. So this process is little bit slow, so we have to do it properly so that there are no DRC errors. DRC stands for design rule checking. So as you can see, now I have made the connections. I have connected the V out also. So these connections I have made. The blue connections are the metal connections and the green connections are the polysilicon connections. Now we have to connect this terminal also. So we will take a P and select the layer as the metal one drawing. So on the left hand side you can see the layer palette. So if you want to make a metal connection, then you have to choose the layer as metal one. If you want to make a polysilicon connection, then you have to choose the layer as polysilicon. Similarly, earlier when we chosen the N well, then the layer that we took was N well layer. So in the left hand side, the layer palette you can see shows all the layers. So as you can see, this connection has also been made. So I am doing it very slowly so that there are no DRC errors. Because even if there is slight change in the dimensions or slight deviation, then it will give us error. So now I will create a via. Via is used to connect a polysilicon to a metal. So as you can see, this is the input A. We have two inputs A and we have to connect this to the gate. The gate is polysilicon, the input is metal. So we have to create a via. So to connect, so we choose a via as metal to poly. So now we will create a path. So just click on P. So this is a metal path and we will connect it to the white contact point. So as you can see, the metal to poly connection has been made using a via. For second input also we will do the same. We will take a via and connect it to the second input. So as you can see, I have taken a via, rotate it. So as you can see, this via is connected to this polysilicon path and we have this input. This blue rectangle denotes the second input B. So we will connect it to this via. So as you can see, our second input B is also connected. Now we will connect the transistors to the ground and the VDD. First, let me make a P well for this NMOS also. So it will be a dummy P well. So as you can see, this dummy P well is created. Now I will share this dummy P well with the second transistor also. So as you can see on the left hand side, I am selecting the layer as the P dummy, PW dummy. So the PW dummy is selected and I am creating now a path. I am creating a rectangle. So as you can see, you can press on the R key of the keyboard to create a rectangle. So we will create the rectangle so that both transistors share the same dummy P well. So as you can see, this rectangle I am creating. So this is the P well, dummy P well. So yes, the dummy P well is created and both the transistors will share this well. Now we will create the rails for the ground and VDD. So I will show you how to create horizontal or vertical rails now. So we can do it from connectivity also. We can choose from pin placement. So let me see if this works. Okay, so rails are not created. Anyways, we can do them by this rectangle option only. So as you can see, this is the VDD. I have attached it to the top boundary of the PR layer. Now I will choose the layer as the metal one drawing and create a rectangle by simply pressing the R key of the keyboard. So as you can see, I will now create a rectangle. The rectangle will be attached to the PR boundary. So that will be a horizontal rail. So just let me draw the rectangle for the horizontal rail for VDD. So as you can see, I am creating a rectangle and this is a horizontal rail. So this horizontal rail is created for VDD. Now any connections we make to this horizontal rail will be part of VDD. Similarly, we will create a horizontal rail for the ground connection also, for the ground pin also. So this is a metal rail for the ground pin. This is also created. Now we will simply make the connections. So the source of the transistor is connected to the body and to the VDD. So this is the connection of the PMOS to the VDD. Similarly, we will connect the NMOS to the body and to the ground. So as you can see, both the transistors are connected to the ground via the body. Yes, the connections are now over. We have completed the connections for our CMOS NOR gate. So please like and share the video and subscribe the channel. Now we will run the DRC and we have made all the proper connections. So there should be no DRC errors. Just let me check. So we will click on OK. DRC is running. So you can see no DRC errors are found. This is a first stage of success. Now we will run LVS layout versus schematic. So we will compare our layout with schematic and we will see there are no errors, no mismatches should be there. So as you can see, 0 cells have mismatches. There are no mismatches. So it means LVS has also been passed. Schematic and layout are matching. Now we will simply do the RC extraction for this. So just run RCX extraction and click on OK. So it will generate the parasitic resistances and parasitic capacitances, which are called as P resistance and P capacitance. These are parasitic. So as you can see, this is the RC extraction view of the circuit. So thank you. This is the complete video for the CMOS NOR gate. I will make more layouts in the future. So please like the video and share the video and subscribe the channel for more such videos on VLSI. Thank you. And for your feedback and comments are always welcome. So post your feedbacks and comments in the feedback section. We can also create the label for these pins. Thank you.